Hi everyone, my name is Mario. This is software design principles are practical approach with Python. Software design is fundamental in building robust, scalable, and maintainable application. There are several principles that guide how we structure code. The answer is efficient and sustainable over time. In this short article, we will explore some of the most important software design principles and apply the real world example using Python. Number one, single responsibility principle. This is principle it states that the class of module should have one and only one reason to change, meaning it should have a single responsibility. If a class has multiple responsibilities, it becomes harder to maintain and understand. And this is code. The order class is responsibility only for calculating the total order amount and storing the details. It does not handle other responsibilities like saving the order to a database, which will be handled by separate class. As we will see later, to open close principle. This principle suggests that code should be open for extension but closed for modification. This means that we should be able to add new functionality without modifying the existing code. This example here we have payment method base class that defines the calculate total method, the credit card payment and PayPal payment class extend this base class and apply there are rules for calculating the order total. If we wanted to have more payment or methods in the future, we could simply add new class without modifying the original code. 3. The scope substitution principle. This principle states that every class must be substitutable for their base class without altering the correct behavior of the program. This is example. The order service class accepts any instance of payment method, whether it's a credit card payment or PayPal payment, and processes the payment without worrying about the exact implementation of the payment method. This demonstrates that we can substitute any subclass for its base class without breaking the expected behavior of the system. Number 4, interface segregation principles. The interface segregation principle tells us that we should not force classes to implement interfaces that are not used. Instead of having a one large interface, we should have several smaller one each covering a cohesive set of operations. This is example. Each class implements only the methods necessary for the respective payment type. Credit card processor only have PayPal processor only has a method for processing PayPal payments. This follow this interface segregation principles, ensuring that no class is forced up to implement methods it doesn't need. Number 5, dependency inversion principles. The dependency inversion principles state that high level class should not depend low level class. but no abstraction. Moreover, abstraction should not depend on details, but details should depend on abstractions. And this is example. The order service class depend on the payment method abstraction to the process the payment. It doesn't depend on only credit payment method like credit card payment or PayPal payment. This makes it easy to change the payment method without modifying the order service class, adhering to the deep principle. In conclusion, software design is a crucial discipline for developing clean, scalable, and maintainable application by following principles such as SRP, XCP, LCP, ESP, and DP. We can write more modular, flexible, and robust code. Through practical examples in Python, we illustrate how to apply this principle in work projects. Adopting this principle not only improves the quality of our code, but also facilitates teamwork and the evolution of application over time. If you want to create quality software, incorporating these principles into your daily development practices is essential.